To discuss about production process painting. Presenter Anil Kumar Sahni, dated 25th January 2020. Introduction. As a Anil Kumar Sahni, production engineer, BSc engineering in production engineering. Painting. What is painting? Painting is a process by which we are protecting the bare material from the corrosion or any environmental effect or damage. So the process of coating is known as the painting. Here we can discuss about the painting process, how painting is being done, what is the sequence of the activities. That means the flow diagram. First of all, we will discuss the flow diagram regarding the painting processes in industries. So move on. First of all, we need to pre-blast check. Before the blasting, we need to check the material condition. Either there is a grease or any lubricant is on that. Because if there is a grease or any lubricant, the paint material, the adhesiveness of the paint material will go down. So we need to check the pre-blast points. That means the conditions, material conditions, any extra things, any foreign materials or anything that may create problem in painting process. So first of all, need to check pre-blast check. Then after surface preparation. Surface preparation means we need to do blasting either by sand or by the abrasive grit. So whatever method is as per ITP, we need to check and do surface preparation. That means the blasting. With the pressure we are shooting by help of the grit over the material. Then a layer of the material, that is the maybe mill scale or some instant of corrosion surface, that may be removed due to the high pressure shot. So that is the surface preparation. The surface preparation required is SN half, 2.5. So as per quality, we need to check it. Then cleaning. After the blasting, the sands or grits are accumulated around the job, and some extent of sand particle or the grit particle will be on the surface of the blasted area, blasted material. So we need to clean that one with the help of air pressure. We need to clean this surface area so it, it will be ready for the primer painting. If there is a dust particle or anything, the adhesiveness of the primer will be less, or maybe it creates some surface unevenness. So we need to clean it. And after in-process inspection, after blasting, cleaning, we need to raise the RFI to the concerned department. QA/QC engineer will come and check the surface preparation, either it is SN 2.5 or not. With the comparator, we are checking this one. The surface, is this surface is ready for painting or not? After the inspection, it is being released for the further process. Check coating system is general drying and part drying. Now, if the surface preparation is okay, now we need to move forward and check the coating system from the ZA drawing or production procedure, painting process. There was a mention in the coating system. So from there, we need to choose the paint, which paint should be applied as a primer, and what TFT should be applied. After that, you need to check from the GA, because if you are making mistake, then it will be problematic. So you are checking from the drawing, is it available? If yes, then raise MIR, material issue requisition, to the store and take material from there. Receive material from there. If no, then raise issue to engineering department that the painting system is not provided in ZA drawing or technical spec. Raise MIR. After receiving the painting material, you do the next process. Mix the coating properly. Means prepare the coating. Apply primer coat on the blasted surface as per required DFT. Check DFT. If okay, as per the required drawing, as per the required painting procedure, as per required ITP, it is okay. Then apply intermediate coat. If not okay, then apply primer coat again until the required TFT is not being achieved. After applying the intermediate coat, check the DFT again. If not okay, then apply the intermediate coat again. If okay, then move for the further activity, apply final coat. In between that, if the inspector is interested, or as per the ITP, if intermediate is the whole point, then you need to check and raise RFI again for the inspection for intermediate coat also. If it is allowed to move on, then you need to move for the further final coat application. Check DFT. Final, if you applied the final coat, then check DFT again. If okay, then raise RFI to the final inspection to the QAQC department. QAQC engineer will come, he will check the final DFT and the painting condition, the color, shade, everything he will check, and he will raise to RFI or the client inspection. And he will intimate to client to check the final inspection of the painting. If not okay, then apply final coat again. This is the whole painting process system. It's the flow activities, flow diagram. In this sequence, you need to do the painting. Now we come on the painting system. What will be the painting system? At term here we are discussing about gas modular, OPTF and annual realizer. As per your company requirement, whatever the painting procedures and the document should technical spec is should for your particular job, you need to check that one. Here we are discussing about the gas modular split. Here we are applying painting system, that is APCS. So, here for the gas modular, it is given by the client the APCS 26. This epoxy masking coating self-priming. The surface preparation is required as a 2.5 SP10 40 to 65 micron, and primer required is TFT, intermediate coat. The surface pressure this primer is 150 to 200 microns. Intermediate coat is not applicable here in APCS 26 system. Top coat is applied 150 to 200 micron, and total DFT is 300 to 400 micron, and final color shade is aluminum RL 9006. So all this system is being provided by the client in the technical spec. From there, we are preparing our self-painting procedure and we are taking approval from the client. And as per this system, we are applying the paint system on the material. So we'll move on the next. Similarly, in the OPTF, there is a painting procedure system documented attached here. Similarly, you should follow. Now, what machinery we have to use? So, machinery list is the airless painting machine. This is the airless painting machine. Compressor need for the air pressure. Air receiver, this is for accumulating the air. Sandblasting pot, 200 liter capacity. The sandblasting pot, or you can use the grate also. Here we are talking about the sand, but we can use grate also. Breathing pot. This is the breathing pot. Sandblasting arrangement. You see, this is the compressor. On the compressor, the pipeline is going to the air receiver. From the air receiver, the pipeline is going to the sandblasting pot, capacity 200 liter. From the air receiver, air line is going to the air breathing pot. From the air breathing pot, one hose, the sandblasting hose, and this is the air breathing helmet. One pipeline is going to the air breathing helmet through the sandblaster gun. So why this air breathing pot is required? It is help to take breath people. People can take breath and fresh air. Hood and blasting hose, and finally one connection is from the sandblasting. So this is the connection system or sandblasting arrangement. This is the outlet. From this outlet, the one connection is going to the short blasting gun, and from this inlet and the outlet, this is the inlet. The air receiver, this coming in this inlet, breathing pot inlet, and from the breathing pot outlet, the connection is going to the air breather inlet. Now the venting arrangement. This is air compressor. From the compressor, air receiver, and connection is going to air receiver. From air receiver to one connection is going to air bending machine, airless venting machine. From airless venting machine, this is a spray gun. A spray gun with hose. This is the air mixture, pneumatic paint mixture. This inlet, this outlet, the air inlet. So this is the painting arrangement system. So thank you. That is the end. Thank you very much.